If I would need to describe the calculus, I would say that the calculus is the study of functions. We've seen about a bunch of different types of the functions before, and we make the analysis on them. So we started with a single variable functions where the input would be the scalar and the output is a scalar. For example, we can say that the f of x is equal to the x squared, and if I put some input to be equal to the 1, it gives me the output f of 1, which is equal to the 1. Then later on, we've seen the vector functions, which are given in this form, where the input t is a scalar and the output would be a vector. For example, if the r of t is given as the vector, cosine of t, sine of t, and if I put some input t to be equal to the 0 as a scalar, the output would be r of 0, which is cosine of 0, and sine of 0, which is 1 and 0. So the output would be a vector. And later on, we've learned about the multivariable functions where the input would be a vector. In this case, this is the vector, three-dimensional vector, and the output would be a scalar. For example, f of x and y would be given as the x squared plus ty. And if I input some vector, t and 1, it would give me a scalar, which would be 4 plus t, which is 6. The output is a scalar. And another type of the functions which we're going to learn are called the vector fields. In general, they are given as a vector, which takes as an input some vector and gives me back another vector. So the input is a vector and the output is a vector. So in general, we write down the vector fields, which depends on x and y, for example, as some function which depends on the x and y multiplied to the I components. This would be the first component of this vector, plus another function g of x and y multiplied to the j. This would be the second component of this vector. So, or I can write this down as f of x and y and g of x and y. An example of the vector fields would be the field of the wind speed, wind velocity over some geographical place. So these arrows are going to show me the direction and the magnitude of the wind velocity in the two different times. And you may see here the direction of the velocity, and also with the different colors, we can denote the magnitudes of the vectors. Let's consider an example of the vector field. The vector field f has the first component as this function and the second component as this function. So in order to illustrate you how it works, so let's say we would like to evaluate the output of this vector field at the point t and 1. So let's choose t and 1 and evaluate what kind of vector we could have if I substitute t and 1 into this vector. So let's evaluate the first component. It would be 4 minus 1 minus 4 multiplied to the I plus t multiplied to the t multiplied to the 1 multiplied to the j. So this vector would be minus I plus 4j, or at the same time I can write this as the minus 1 and 4. So let's draw this vector here on the xy plane. So I need to start the vector from the origin because this is the position vector, and this vector goes to the minus 1 and 4 point. So this is going to be this vector. So since my point is here, t and 1, without changing the direction and the magnitude of this vector, I could move it to here. So it would be 1 unit to here and 4 units to here. And we could draw the same vector here. So when we say that we're given some vector field f on the xy plane, it means that for every single point, we would draw the vectors. So obviously we can just decrease the length of the vectors so that we will have more clear picture of the vectors and denote the magnitudes of the vectors with the different colors. So this vector field can be drawn differently for all the points in this way. So for example, in this point, roughly, which is t and 1, the vector would have this direction, or at this point, at the 0 and 0, that the vector would have this direction.